April 12, 1941, River Rouge Plant, Dearborn, Michigan. The morning sun broke through the industrial haze above Detroit, casting long shadows across the largest integrated factory complex in the world. Inside the cavernous Building B of Ford's River Rouge plant, a space so vast that weather systems could form beneath its roof, an unusual silence had fallen. The assembly lines that normally thundered with the rhythm of automobile production, the clang of steel, the hiss of pneumatics, the relentless forward march of conveyor belts, stood motionless. 3,000 workers, men in oil-stained coveralls and women in headscarves and workdentures, gathered in clusters, their faces turned toward a raised platform where a single man stood beside a peculiar wooden mock-up. The structure looked like the skeleton of a tank turret, but built from pine and plywood, its dimensions marked with chalk lines and measurements. The air smelled of machine oil, sawdust, and the metallic tang of steel shavings. Somewhere in the distance, a rivet gun fired in staccato bursts, but here, in this moment, the workers waited. The man on the platform was not a general. He was not a weapons designer. He wore no uniform. John Crawford Williamson, 47 years old, chief production engineer for Ford Motor Company, adjusted his wire-rimmed glasses and looked out at the sea of skeptical faces. In his hands he held a simple stopwatch and a clipboard covered in pencil sketches. He had been given an impossible task: transform an industry designed to build civilian automobiles into a machine capable of producing armored fighting vehicles at a rate the world had never witnessed. The military experts said it could not be done. Tank production was specialized, artisanal work requiring skilled craftsmen and months of hand-fitting components. But Williamson, who had spent 20 years perfecting the assembly line techniques that could produce a Model T every 24 seconds, believed something the experts did not: that the principles that made cars cheap and abundant could make tanks the same. What happened in the months and years that followed would transform not just how tanks were built, but how wars were won, and would shake the foundations of every military doctrine that assumed quality and complexity were synonymous with superiority. To understand the revolution Williamson was about to unleash, one must first understand the world of tank production as it existed in 1941, and why his vision seemed not just ambitious, but genuinely impossible to everyone who had ever built an armored vehicle. The Artisan's War Machine. In the spring of 1941, as Nazi Germany's panzer divisions carved through the Balkans and prepared for the invasion of the Soviet Union, tank production across the world was still fundamentally a craftsman's trade. Tanks were built in specialized arsenals and armament factories where skilled metal workers hand-fitted armor plates, where gun mechanisms were assembled by expert gunsmiths, where each vehicle was essentially custom-built by teams who might spend weeks on a single machine. This was true in Germany's Henschel factories producing Tigers, in Britain's Vickers facilities making Crusaders, and in the Soviet Union's tank plants around Kharkov producing T-34s. The American experience was no different. Arguably, it was worse. In 1940, when Congress finally authorized expansion of America's armored forces, the United States possessed exactly 464 tanks of all types, most of them obsolete light tanks that would have been death traps against German armor. American tank production was concentrated in a handful of arsenals like Rock Island and Watervliet, government facilities where production rates were measured in single digits per month. These were institutions designed around the peacetime military philosophy that prioritized minimal expenditure and treated each tank as a precision instrument to be carefully crafted by expert hands. The process of building a medium tank in 1940 involved over 5,000 individual parts, each machined to exacting tolerances, then assembled through a combination of riveting, welding, and bolting that required highly skilled labor. The hull alone demanded thick armor plates that had to be cut, shaped, heat-treated, and fitted together with overlapping joints. The turret mechanism required precision machining to ensure smooth rotation. The engine, transmission, and drivetrain were adapted from various sources and required custom fitting into the hull. The suspension system, with its bogie wheels and return rollers, demanded individual adjustment. The entire process, from raw steel to finished fighting vehicle, could take 3 months or more and required craftsmen whose training might span years. When the War Department issued initial orders for expanded tank production in 1940, calling for 500 medium tanks to be delivered within a year, the existing arsenals declared the timeline impossible. The problem was not just capacity, it was philosophy. Tank building was considered a specialized military art, fundamentally different from civilian manufacturing. Tanks were not consumer goods. They were complex weapons platforms that required military expertise, security clearances, and specialized knowledge that civilian factories simply did not possess. John Williamson, reading these declarations from his office overlooking the River Rouge assembly lines, understood immediately that everyone was asking the wrong question. They were asking, how can we build more tanks using existing methods? Williamson asked something different. What if we stop treating tanks like weapons and start treating them like Model T Fords? The Heretic's vision. Williamson's background made him uniquely positioned to see what military engineers could not. He had started at Ford in 1919, just as Henry Ford's assembly line revolution was reaching its poor apex. He had watched raw materials enter one end of the River Rouge complex and finished automobiles roll out the other end in a continuous, choreographed flow that seemed to defy the laws of manufacturing efficiency. He understood something that would sound obvious, stated plainly, but was revolutionary in practice. The complexity of a product mattered far less than the design of the process that built it. An automobile, properly analyzed, is not simple. It contains thousands of parts requiring precision machining, electrical systems, hydraulic brakes, synchronized transmissions, and engines where tolerances are measured in thousandths of an inch. And yet, by 1941, Ford's River Rouge plant was producing over 5,000 vehicles per day. Not per month, per day. The plant consumed coal by the trainload, melted iron ore into steel on site, stamped body panels from rolls of sheet metal, cast engine blocks, machined crankshafts, assembled entire vehicles, and drove them off the line under their own power, all in a continuous flow that had reduced the time from raw material to finished automobile to less than 48 hours. Williamson's insight was brutal in its simplicity. A tank was just a car with armor and a gun. If you could redesign the tank to use standardized parts, eliminate unnecessary complexity, and organize production around continuous flow rather than batch craftsmanship, you could apply automotive mass production techniques to what everyone else treated as artisanal military hardware. This was heresy. When Williamson first presented his ideas to a War Department procurement board in late 1940, he was met with polite but firm dismissal. A colonel from the Ordnance Department explained, with the patience reserved for civilians who did not understand military matters, that tanks were not automobiles. They required specially hardened armor that had to be fitted precisely. They required military specification components that could not be mass-produced. They required skilled armament workers who understood weapon systems. The idea that an automobile factory, no matter how efficient, could produce combat vehicles at automotive speeds was fantasy. Williamson asked a simple question in return: what if we prove you wrong? The War Department, desperate for production but skeptical of promises, offered a compromise. Ford Motor Company would be granted a contract to produce a new medium tank design, the M4 Sherman, based on earlier prototypes, but only if Williamson could demonstrate that his methods could actually work. He would be given access to the blueprints, technical specifications, and military consultants. If he could tool up a production line and build tanks at rates exceeding what military arsenals achieved, the contract would expand. If he failed, the experiment would end, and production would return to traditional methods. Williamson accepted immediately. He had 6 months to transform theory into reality. The Bois transformation begins. What Williamson did next would become legendary in manufacturing history, studied in engineering schools and business courses for decades after. He approached the Sherman tank not as a military vehicle to be replicated, but as a design problem to be solved through the lens of mass production. He began by having the entire tank disassembled into its component parts, every bolt, plate, gear, and wire laid out in Building B like an exploded view diagram 300 feet long. Engineers, draftsmen, and shop foremen were assigned to analyze each component and ask 3 questions. Can this be standardized? Can this be simplified? Can this be made on existing equipment? The results were revolutionary. The Sherman's hull, originally designed with complex curves and overlapping armor plates that required skilled welders, was redesigned with simpler angles and flat plates that could be stamped from sheet steel using automotive body presses. The riveting process, which required teams of skilled riveters working for days, was replaced where possible with welding techniques adapted from ship construction, and where rivets remained necessary, the holes were redesigned to accept standard sizes. The turret rotation mechanism, originally a custom-built system, was re-engineered using modified truck transmission gears. The suspension bogies, each originally fitted individually, were redesigned as modular units that could be bolted on in minutes. Most radically, Williamson broke the tank down into subassemblies that could be built simultaneously on separate production lines, then brought together for final assembly, exactly the way Ford built cars. One line would produce hulls, another would produce turrets, another would focus on engines and drivetrains, another would handle the suspension assemblies, another would work on electrical systems and gun mechanisms. Instead of building tanks one at a time from start to finish, the factory would build hundreds of components simultaneously, then marry them together at the final assembly stage. The military consultants assigned to monitor the project were horrified. This was not how you built military equipment. Tanks required individual attention, careful fitting, and expert oversight at every stage. Williamson's assembly line approach would result in poor quality, they warned, loose fittings, misaligned components, vehicles that would fail in combat. Williamson's response was to invite them to watch the test assembly. In January 1942, 9 months after that meeting in Building B, the first Sherman rolled off Ford's pilot production line. It had been assembled in 14 hours, start to finish, from subassemblies that had been built simultaneously. Military inspectors examined every weld, every bolt, every tolerance. They found the quality equaled or exceeded the hand-built tanks from military arsenals. More importantly, the standardization meant that parts were truly interchangeable, a radical concept in military production. A turret built on Tuesday would fit any hull built on Wednesday. A suspension bogie from one tank could be swapped onto any other tank. This was commonplace in automobile manufacturing, but revolutionary in armaments. The production rate climbed rapidly. By March 1942, the Ford plant was producing 1 Sherman tank every 4 days. By June, 1 per day. By September, 1 every 8 hours. By December 1942, the River Rouge complex and Ford's new purpose-built tank arsenal at Willow Run were collectively producing 1 Sherman tank every 2 hours, 24 hours a day, 7 days a week. The implications were staggering. Ford alone would eventually produce over 8,000 Sherman tanks before war's end. But Ford was just the beginning. Williamson's methods were documented, codified, and shared across America's industrial base. Chrysler's Detroit Tank Arsenal built from scratch using Williamson's principles, would produce over 18,000 Sherman variants. Fisher Body, a General Motors subsidiary, converted automobile plants and produced over 11,000 more. Pressed Steel Car Company, which had built railroad cars, produced over 8,000. Baldwin Locomotive Works, Federal Machine and Welder, Pacific Car and Foundry, companies that had never built military equipment, successfully transitioned to Sherman production using the standardized designs and process documentation that Williamson's team developed. The American war machine had learned to produce tanks the way it produced refrigerators and tractors and automobiles in massive quantities with consistent quality, from standardized designs that prioritized ease of production over theoretical perfection. What the enemy expected. In Berlin, as intelligence reports about American industrial mobilization reached the desks of German military planners in 1942, the response was dismissive to the point of contempt. The report seemed absurd on their face. American automobile factories were claiming they could produce tanks faster than German tank production, using workers with no military manufacturing experience, building vehicles with interchangeable parts as if tanks were consumer appliances. Reichsminister Albert Speer, Hitler's Minister of Armaments and War Production, understood industrial capacity better than most Nazi officials. He was an architect by training, but had become the Reich's chief industrial organizer. Even he found the American claims implausible. German tank production was centered in specialized facilities where expert workers crafted each vehicle with precision. The idea that untrained American factory workers, many of them women who had never worked in heavy industry before the war, could match German production was laughable. That they could exceed it was impossible. The German expectation was rooted in a fundamentally different manufacturing philosophy. German industry prized craftsmanship, specialization, and continuous improvement of designs toward theoretical perfection. Each new tank model, the Panther, the Tiger, the King Tiger, incorporated lessons from combat and pushed the boundaries of what was technically possible. Thicker armor, more powerful guns, better optics, more sophisticated fire control systems. These were not vehicles designed for mass production. They were weapons designed to be superior. This philosophy produced remarkable machines. The Tiger Wars, introduced in 1942, was arguably the most feared tank of the war, nearly invincible frontally, capable of destroying enemy armor at extreme ranges, a psychological weapon as much as a physical one. But each Tiger required over 300,000 man-hours to produce. The complex, interleaved road wheels alone required hundreds of hours of labor. The precision-machined transmission was so delicate that it frequently failed under the stress of the tank's 60-ton weight. The Maybach engine, while powerful, was temperamental and required careful maintenance. Production rates never exceeded 25 Tigers per month, even at peak output. German planners calculated that quality would overcome quantity. One Tiger, they reasoned, was worth 5 or even 10 American Shermans. This was not mere propaganda. Combat records from Normandy and later battles supported this assessment. A single Tiger, properly positioned and supplied, could devastate entire columns of Allied armor. The mathematics, from the German perspective, were straightforward. If Germany could produce better tanks, manned by better trained crews using superior tactics, then American numerical superiority would be blunted. What German planners failed to appreciate was that Williamson's revolution had changed the fundamental equation. The question was not whether one Tiger could destroy 5 Shermans. The question was, what happens when America can produce 50 Shermans for every Tiger Germany builds and can replace losses overnight, while German panzers, once destroyed, were gone forever? What they actually faced. The reality of American production capacity hit German military planners like a physical blow when the true numbers began to emerge in 1943. Intelligence services had intercepted production figures that seemed to contain typographical errors. American factories were reporting monthly tank production exceeding what Germany produced in a quarter. The figures were verified, re-verified, and finally accepted with a kind of numb horror. By 1943, American factories were producing over 2,000 tanks per month, not just Shermans, but also light tanks, tank destroyers, and specialized variants. The production kept accelerating. By 1944, monthly production exceeded 4,000 armored fighting vehicles. The total production numbers told a story that German strategic planners found genuinely frightening. While Germany would produce approximately 25,000 tanks and assault guns of all types during the entire war, the United States alone produced over 88,000 tanks and self-propelled guns, of which nearly 50,000 were Sherman variants. But the numbers, staggering as they were, did not capture the true revolution. What Williamson's system created was not just volume, but sustainability. The standardization that made rapid production possible also made maintenance and repair revolutionary. Every Sherman used the same basic components. A damaged final drive could be replaced with one from any other Sherman. A burned-out engine could be swapped for a new one in a matter of hours using a standardized engine package. Damaged armor could be patched or replaced using standard plate sections. The entire vehicle was designed not just to be built quickly, but to be repaired quickly and kept in service indefinitely. German tanks, by contrast, were maintenance nightmares. The Panther's Maybach engine required 60 hours of skilled labor to remove and replace. The Tiger's transmission, when it inevitably failed, often meant the entire tank had to be transported back to depot-level maintenance facilities, if such facilities existed and could be reached. The sophisticated components that made German tanks superior in combat made them vulnerable to the grinding reality of sustained warfare. Field Marshal Erwin Rommel, whose Afrika Korps had been the first to face American armor in large numbers, wrote in his diary in November 1942 after the Battle of El Alamein, "The Americans bring an entirely new form of warfare. Their tanks are individually inferior to ours, yes, but they have so many, and they keep them running. We knock out 10 and 20 appear. We destroy those, and 30 more arrive. And all of them work. All of them have fuel. All of them have ammunition. This is not a battle of tanks against tanks. It is a battle of one tank against an inexhaustible flood." After action reports from German panzer units in Normandy consistently noted this disparity. A Tiger crew might achieve a remarkable kill ratio in an engagement, destroying 6, 8, even 10 Shermans before withdrawing. But the next day, the Shermans would be back in equal numbers, while the Tiger, if it had suffered any mechanical damage or was low on fuel, might be abandoned for lack of supplies or spare parts. German commanders found themselves winning tactical victories that meant nothing because American armor could absorb losses that would have crippled any other army and return to combat strength within days. General Heinz Guderian, the architect of Germany's panzer tactics and later Inspector General of Armored Troops, wrote bitterly in his memoirs, "We built the finest tanks in the world. But the Americans built a tank-building system. When you fight a system with individual examples of excellence, the system wins through sheer persistence. I understood this too late." The human element, the Revolution Williamson, created was not just mechanical, it was human. The transformation of tank production from artisanal craft to assembly line manufacturing required a corresponding transformation in who could build tanks and how they were trained. In 1940, American military arsenals employed skilled metalworkers, many with years or even decades of experience. These were men who had apprenticed in the trade, understood metallurgy and machining, could read complex technical drawings, and possessed the judgment to hand-fit components when specifications did not match reality. There were not enough such workers in America to staff massive tank production, and training new ones required years. Williamson's system eliminated the need for universal expertise. By breaking tank production into standardized subassemblies and simplifying each manufacturing step, he created jobs that could be learned in weeks rather than years. Stamping hull plates required operating a press, not understanding armor theory. Welding along marked seams required following clear guidelines, not making complex judgments about heat treatment. Bolting together pre-assembled modules required basic mechanical aptitude, not years of training. This opened tank production to an entirely new workforce. Women, largely excluded from heavy manufacturing before the war, comprised nearly 40% of the workers at peak production. The famous Rosie the Riveter was not just propaganda, she was real, repeated thousands of times across American tank plants. African Americans, previously restricted to segregated and limited roles, found opportunities in the integrated, if still imperfect, production lines where skill mattered more than background. Older workers, thought too old for the precision work of traditional armaments, thrived in the specialized roles of assembly line production. Even disabled workers who could not serve in combat found meaningful contribution operating specific stations on the production line. The photographs from Ford's Willow Run and Chrysler's Tank Arsenal show floors filled with diverse faces, young and old, male and female, people of different races and backgrounds, all building the instruments of war with the same techniques that had built America's consumer abundance. This was democracy weaponized, not through ideology, but through participation. The workers understood what they were building. Unlike German factory workers, increasingly composed of slave laborers from occupied territories who had every incentive to sabotage production, American workers were volunteers building weapons for sons, brothers, and husbands fighting overseas. Quality control did not require Gestapo supervision. It was self-enforcing, motivated by the knowledge that sloppy work meant dead Americans. Stories emerged of workers staying after their shifts to fix defects they noticed, of welders who marked their work with personal stamps, taking pride in craftsmanship even within mass production, of entire factory floors that would gather when news arrived of battles where their tanks had fought, celebrating victories and mourning losses with a personal connection to the machines they had built. This human element created a feedback loop that German production could never replicate. American tankers wrote letters from the front praising the Sherman's reliability and requesting specific improvements. These letters reached the factory floors where engineers and workers would implement changes, better ventilation, improved ammunition storage, thicker armor in vulnerable spots, that would appear in new production within weeks. The famous wet stowage modification, which dramatically reduced the Sherman's tendency to burn when penetrated, went from field observation to standard production in less than 6 months. German tank improvements, by contrast, required months or years of bureaucratic approval and redesign. The American system had created what modern theorists would call rapid iteration, the ability to learn, adapt, and improve faster than the enemy could respond. This was only possible because Williamson's standardization allowed changes to propagate quickly across the entire production network. The symbol of the rivet. In the turret of every early Sherman tank, in the corners where armor plates joined, were hundreds of small steel rivets, each one driven home by a pneumatic gun in a sharp metallic crack that echoed across the factory floor. The rivet, that humblest of fasteners, became the unlikely symbol of everything Williamson's revolution represented. To traditional military engineers, the rivet was a compromise, less strong than welding, more prone to failure, a mark of cheap construction. German tanks increasingly used welding exclusively, seeing it as superior craftsmanship, but Williamson understood what the military engineers did not. The rivet was not just a fastener, It was a philosophy. Rivets were fast. A skilled riveter could drive dozens per minute. Rivets were standardized, the same size, the same strength, interchangeable. Rivets could be installed by workers with modest training, using pneumatic tools that required more rhythm than expertise. Rivets could be replaced in field conditions if damaged. Rivets allowed armor plates to be prefabricated separately, then assembled rapidly. The rivet was everything German engineering philosophy disdained: simple, mass-producible, good enough rather than perfect. And yet, those thousands upon thousands of rivets held together the tanks that buried the Third Reich. Workers in the tank plants developed an almost affectionate relationship with the sound of the rivet guns, the sharp tock, 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 tock that signaled progress, that meant another hull was coming together, another tank would roll to the front. The rhythm of riveting became the heartbeat of the factories, a percussion that never stopped during war production. 3 shifts, 24 hours. The rivet guns sang their metallic song. When news reached the home front of American victories, North Africa, Sicily, Normandy, the Bulge, factory workers knew that their rivets were there, holding armor plates together while American tankers fought. When news came of losses, of Sherman's burning, the same workers returned to their rivet guns and built more, faster, better. The rivet was a promise: we will overwhelm you with abundance. We will produce faster than you can destroy. Every rivet is a vote for democracy, cast in steel, driven home with pneumatic force. German tankers who saw American tank production facilities after the war were stunned by the simplicity. They had expected factories like the ones in Germany, dark, precise spaces where craftsmen worked on individual machines with specialized tools. Instead, they found bright, vast floors where hundreds of workers stood at individual stations, each performing one repetitive task, and from this seemingly mindless repetition emerged an endless stream of functional tanks. It seemed almost insulting. War machines built like children's toys, stamped and riveted and bolted together without artistry or individual attention. But those same German veterans understood, with the bitter wisdom of defeat, that they had lost to those rivets. Not to superior design or better tactics or braver soldiers, but to a system that could produce 10,000 rivets per tank, 50,000 tanks per year, and replace every loss faster than they could inflict damage. The rivet, in its humble way, had driven home the final nail in the Wehrmacht's coffin. The ideology of abundance. What Williamson created was ultimately not a manufacturing process, but a demonstration of ideological superiority rendered in steel and industrial organization. The assembly line was democracy's answer to fascism's cult of the exceptional. Nazi ideology at its core was romantic and aristocratic. It celebrated the exceptional individual, the hero, the genius, the master craftsman. This romanticism extended to its weapons, each tank a masterwork, each design pushing the boundaries of what was possible, each vehicle a testament to Aryan technical superiority. The Tiger tank was not just a weapon, it was a statement that German engineering genius could overcome numerical odds through quality. Quality was destiny, and destiny favored the master race. American ideology, particularly as expressed through the assembly line Williamson perfected, was fundamentally democratic and egalitarian. It assumed that ordinary people, given the right tools and organization, could achieve extraordinary results. It did not require genius, it required system. It did not celebrate the exceptional, it celebrated the aggregate. 1,000 ordinary workers, properly organized, could outproduce 100 master craftsmen. This was not just economic theory, it was philosophy made manifest. The Sherman tank embodied this philosophy. It was not the EOS best tank. It was not trying to be the best tank. It was trying to be everywhere, always, in sufficient numbers that best became irrelevant. It was trying to be simple enough that mechanics could fix it, common enough that spare parts were always available, reliable enough that it would start every morning, and producible enough that losses were merely statistics rather than catastrophes. This drove German military theorists to distraction. They could not understand why America did not build better tanks. The industrial capacity obviously existed. If America could build 50,000 Shermans, why not build 50,000 of something superior? The answer was that superiority was beside the point. The Sherman was sufficient, and sufficiency in overwhelming quantity was its own form of superiority. General George S. Patton, whose Third Army rode Shermans across France and into Germany, understood this instinctively. In a letter to a friend, he wrote, "Give me 1,000 Shermans over 100 Tigers. The Sherman will be there tomorrow, running, with fuel and ammunition. The Tiger will be abandoned on a road somewhere, out of gas or broken down, no matter how much better its gun is. In war, the weapon that is present and functional beats the weapon that is superior but absent." This was heresy to the German military tradition, which had been built on the principle that superior training, tactics, and equipment could overcome numerical inferiority. It had worked in Poland, in France, in the opening phases of Russia. But it failed against an enemy who simply did not care about individual superiority, who absorbed losses and kept coming, whose doctrine was not elegance, but suffocation. The transformation complete. By 1944, Williamson's revolution had transformed not just American tank production, but the entire philosophy of how democracies could wage industrial war. The techniques developed for the Sherman propagated across the entire arsenal of democracy. Aircraft production adopted the same principles. The B-24 Liberator bomber was produced at Ford's Willow Run using assembly line techniques that allowed a single factory to produce one 4-engine heavy bomber every 63 minutes at peak output. Shipyards building Liberty ships reduced construction time from over 200 days to less than 40 by applying mass production and prefabrication techniques. Artillery, trucks, rifles, ammunition, every category of military equipment saw production rates that would have been considered fantasy before Williamson proved the concept. The United States entered World War II with an army smaller than Portugal's. It ended the war having produced more military equipment than all other combatants combined. This was not because Americans were better engineers or more skilled workers. It was because one engineer in Dearborn, Michigan, had the audacity to believe that the principles that made Model T Fords cheap and abundant could be applied to instruments of war, and the stubbornness to prove it, despite every expert telling him it was impossible. The impact extended beyond the war. Williamson's documentation of his methods, originally classified but later published, became foundational texts in manufacturing engineering. The concepts of modular design, standardized components, parallel subassembly, and continuous flow that he demonstrated at massive scale became the basis for post-war manufacturing across industries. Japanese manufacturing, rebuilt after the war with American assistance, studied Williamson's work and developed it into the Toyota production system, which would revolutionize global manufacturing in the 1970s and 1980s. The principles echo through every modern factory, every supply chain, every product that is designed not just to work, but to be producible at scale. But in the spring of 1945, as the war in Europe ground toward its conclusion, these implications were still future. What mattered in that moment was simpler. American and Allied forces had overwhelming material superiority because one engineer had made the impossible routine. The final count. When the last Sherman rolled off American production lines in 1945, the final tallies revealed the scale of what Williamson's vision had achieved. 49,234 Sherman tanks, 8,753 tank destroyers based on the Sherman chassis, thousands more variants, recovery vehicles, artillery tractors, flame tanks, engineering vehicles, all built in less than 4 years using techniques that had not existed when the war began. Compare this to Germany's production: 6,000 Panthers, 1,347 Tigers, approximately 25,000 tanks of all types across the entire war. The Soviet Union, with its massive heavy industry mobilized for total war, produced over 65,000 tanks, including the T-34. But even Soviet production, impressive as it was, used traditional batch manufacturing techniques that could not match the speed and efficiency of Williamson's assembly line approach. The arithmetic was inescapable and damning for the Axis. In every theater, in every battle, American and Allied forces could absorb losses that would have been crippling to their enemies and return to full strength faster than those enemies could exploit temporary advantages. This was not just a military advantage, it was a psychological weapon. German and Japanese forces fought with increasing desperation as they realized that no victory was final, no losses they inflicted were permanent, and every day brought fresh American equipment in quantities that seemed to violate the laws of industrial production. Captured German soldiers, interrogated about their expectations versus reality, consistently expressed shock at American material abundance. They had been told that America was weak, decadent, more interested in consumer goods than military might. What they encountered was an enemy whose consumer goods factories had become military arsenals without losing the efficiency that made consumer abundance possible. The same principles that made America the land of automobiles, refrigerators, and radios made it capable of drowning the Axis in tanks, planes, and ships. Voices from the floor. Understanding the human dimension of Williamson's achievement requires hearing from those who translated his vision into reality, the workers who stood at assembly lines and built the tools of victory. Rose Monroe, the original Rosie the Riveter, who worked at Ford's Willow Run plant building B-24 bombers using the same techniques developed for tank production, recalled in a 1980s interview, "We knew what we were building. Every rivet I drove, I thought about my husband in the Pacific. I thought about making sure the boys had equipment that worked. We took pride in the work, even though it was repetitive, maybe especially because it was repetitive. It meant we could do it right every time, not just sometimes. Mr. Williamson, he came through the plant regular-like, and he always said the same thing, every part perfect, every time. That was his motto, and we did it. We made every part perfect, every time, millions of times." Charles Nelson, an African-American worker at Chrysler's tank arsenal, described the transformation in his own life and the lives of his co-workers. "Before the war, I was a porter. That's what they let colored folks do. Then the war came, and suddenly they needed bodies on the tank line, and they didn't care what color you were, if you could run a welding torch or operate a press. I learned to build tanks. Me and 10,000 other folks who never thought we'd have the chance. And you know what? We were good at it. Those tanks we built, they won the war. Nobody can tell me colored folks aren't as capable as anyone else, because I built the same tanks as everyone else on that line, and they all worked fine. Mr. Williamson's system, it treated everybody equal. You did your job right. That's all that mattered." The democratization of war production was itself a weapon against fascism. Nazi ideology insisted on racial hierarchy and the supremacy of Aryan genius. Williamson's factories proved that ordinary Americans of all backgrounds could produce extraordinary results through organization and shared purpose. Every tank that rolled off those integrated assembly lines was a refutation of Nazi racial theory, even if the workers themselves did not articulate it that way. The engineer's reflection. John Crawford Williamson did not live to see the full impact of what he had created. He died in 1944 at age 50 from a heart attack brought on by the stress of running tank production through the critical years of the war. His obituary in the Detroit newspapers focused on his work for Ford Motor Company and mentioned his contribution to war production in a single paragraph. He never received a medal or public recognition commensurate with his impact. He was an engineer, not a general, and engineers rarely receive parades. But before his death, Williamson did reflect on what he had accomplished in a speech to factory supervisors in late 1943. His words, preserved in Ford Company archives, reveal how he understood his own work. People ask me how I knew this would work, how I knew we could build tanks like automobiles. The truth is, I didn't know. I believed it was possible because I had seen what was possible with cars. I believed that if you broke a complex problem into simple steps, ordinary people could solve it. I believed that good enough, repeated a million times, beats perfect, achieved once. But I didn't know if I was right until we proved it. What I learned is that democracy's strength is not that it produces geniuses. Every society has those. Democracy's strength is that it harnesses the collective ability of ordinary people and gives them the tools to achieve things individually impossible but collectively inevitable. We didn't build 40,000 tanks because we're geniuses. We built them because 40,000 ordinary Americans showed up every day and did their jobs well in a system designed to make excellence routine. That's the secret weapon nobody expected. This was the philosophy that won the war, not brilliant generalship, not superior tactics, not technological breakthroughs, but the systematic application of democratic principles to industrial production. The idea that ordinary people, properly organized and equipped, could outperform any elite. The legacy in steel. In the forests of Europe, in the deserts of North Africa, in the jungles of the Pacific, rusting Sherman hulks still dot the landscape, monuments to Williamson's vision. Some have been preserved as memorials, carefully maintained to honor those who fought in them. Others remain where they fell, slowly consumed by vegetation and oxidation, becoming part of the earth they fought to liberate. These steel monuments represent something more than military history. They represent the moment when democratic ideals translated into industrial practice and proved capable of defeating totalitarian efficiency. They represent the victory of good enough in overwhelming abundance over perfect in small quantities. They represent the triumph of the assembly line over the workshop, of standardization over customization, of the many over the few. The Sherman tank, for all its flaws and limitations, for all the justified criticism it received from crews who wanted better armor and bigger guns, accomplished what it was designed to do. It was everywhere it was needed, when it was needed, in sufficient quantities that losses were tolerable, and victory was inevitable. This was not an accident of American industrial might. It was the deliberate result of one engineer's vision that what worked for cars could work for tanks if you were willing to rethink everything about how tanks were built. German engineers after the war studied American tank production facilities with the intense curiosity of the defeated trying to understand their conquerors. What amazed them was not the technology, much of it was cruder than German methods, but the organization. The systematic thinking that had gone into every aspect of production, from the design of the factory floor to the training of workers to the flow of materials, revealed a sophistication that German military production had never achieved. One German engineer, quoted in a U.S. strategic bombing survey, said, "We built better tanks. They built a better system. The system won. It always wins." The epilogue in silence. In the summer of 1945, as American soldiers occupied Germany and Japan surrendered after the atomic revelations, the tank production lines in Detroit began to slow. The 3 shifts became 2, then 1. The overtime disappeared. The urgency that had driven production for 4 years evaporated with peace. By 1946, the great arsenal of democracy was converting back to consumer goods. The same lines that had built Sherman tanks retooled to build passenger cars. The same workers who had driven rivets through armor plate now assembled chrome trim and upholstery. The transition was so smooth it seemed miraculous. The same Assembly line techniques, the same standardization, the same focus on mass production and reliability that had won the war, now created the post-war economic boom. The workers who had built tanks built the suburban dream. The engineers who had designed tank production systems designed refrigerator factories and appliance plants. The lessons of industrial warfare became the lessons of industrial peace. But in the corner of Ford's River Rouge complex, in Building B where it all began, they left one relic: the wooden mock-up of a Sherman turret that Williamson had stood beside in 1941 when he explained his impossible vision to skeptical workers. It remained there for decades, slowly deteriorating, a forgotten monument to the moment when one man asked a simple question that changed how wars are fought and won. What if we stop treating tanks like special and start treating them like ordinary? The wooden mock-up is gone now, victim of time and corporate renovations, but the philosophy it represented endures. In every modern factory where complex products are assembled from standardized components, in every supply chain designed for efficiency and reliability, in every system that prioritizes consistent good quality over occasional perfection, Williamson's ghost walks the floor. The Sherman tank was never the best tank, but it was the right tank, built the right way, by the right system, at the right time. It was democracy's answer to fascism rendered in armor plate and rivets, not elegant, not sophisticated, not the choice that military aesthetics would prefer, but present, functional, and overwhelming in its abundance. One engineer's impossible vision made it possible to build a tank as easily as a car, and in doing so, proved that the assembly line was not just an economic innovation, but a weapon, perhaps the most decisive weapon of the 20th century's defining conflict. The victory was not won on battlefields alone, but in factories where the hum of machinery and the crack of rivet guns sang the song of democratic industrial might, transforming ordinary Americans into the arsenal that buried tyranny under an avalanche of good-enough steel. The last rivet driven, the last tank delivered, the last shift ended. But the proof remained, cast in the history written by 50,000 tanks that rolled from civilian factories to win a military victory. That abundance is its own form of excellence, that ordinary people united by purpose can achieve extraordinary results, and that sometimes the most revolutionary act is making the impossible routine.